Thank you, Grace. So, hello everyone. My name is Farhad, and my time is spread across these four organizations that you can see here. And I will be looking at the existing research. But before that, I want to start with a slide on typology of artificial intelligence because, based on my previous experience, it causes a lot of confusion. So, we have different classifications for the AI. So we have one classification that says that we have two categories of artificial intelligence: the AI that learns, and we know it mainly as the machine learning. Machine learning is a way to achieve artificial intelligence, and we have a rule-based. Example of machine learning-based AI is when we are screening titles and abstract in the systematic review tools. That it learns from our decisions. And the example of rule-based AI is, for example, spam detectors in your inbox. So that is one classification. The second classification is discriminative AI versus generative AI. It is important to know these classes because then you know when to go to which one of these categories, depending on your purpose. So discriminative AI, what it does is to look at the data that you provided and then classifies them based on certain characteristics. So it finds the borders between the classes of data in your data set. Generative AI generates content that could be text, image, video. And then we have another classification called supervised AI that learns from the human. So human is the teacher, it teaches the machine, machine is the student, learns, and then based on that learning, we could provide more tasks, more data, and ask the machine to implement the learning into that new data. We also have supervised learning, unsupervised learning, where we present the machine with a lot of information without giving any other information and any other instruction, and the machine is supposed to learn from this data and find, let's say, patterns or trends within that data set. So what is surprising is that we have had artificial intelligence, supervised one, discriminative one, in evidence synthesis for over 15 years. So it is not new. We've been using it for 15 years. It is just the last 5 years that by introduction of large language models that are unsupervised and they are generative AI, that people started making noises that this is great and we are going to do a lot of great stuff with this. But the generative AI and the large language models that are being used by chatbots are suitable, and it has been instructed in their terms and conditions that they are good for generating text, translation, summarization, and question answering. So getting back to the research, so based on this background of classes of AI, we have research done on using large language models and discriminative AI as well to find the PICO questions for the clinical practice guidelines and then prioritize them. So it is useful that we could use AI for finding the PICO questions, which is useful for both clinical practice guidelines and GC purposes. But for the search part of the evidence synthesis, the majority of the tools that are around are good for scoping, for scanning, and not horizon scanning. Recommending the papers. So if you tell the AI that this paper is relevant, it can recommend 5 more relevant papers. And mapping the existing literature. They are not very good at designing systematic search strategies. It's good for collecting the keywords. It's good for writing basic Boolean string that has and or, but it cannot decide which one of the search components or blocks should be included or excluded from the search. Which ones are search resistant concepts. So we don't include entire PICOs into search. It cannot decide it, but it could save time by providing the structure. And then it is very good. AI is very good in automating the update searches. The reason is that from the basic search, the base search or first search that you've done, the machine can learn a lot when you are screening. And when the update search comes in automatically, it can actually classify the records to relevant, irrelevant. It is very useful when you are doing a living evidence synthesis or living systematic review or a systematic review that requires multiple update searches. For the screening part, we've had supervised screening and priority screening since 2020. Prisma 2020 actually mentions it. So we've been using discriminative AI for screening the records. But large language models, using them for title and abstract screening is not better than what we already had. And for obvious reasons, because large language models are good for generating stuff, not discriminating stuff. Obviously, you can teach, you can give instructions to large language models, a lot of instructions. And if you could have a very clean data set input and very clear instructions and very clear output description, then it could be helpful as the second reviewer. But generally, if you don't do all of this, it's good for scoping. So you could upload a file of 2,000 records and ask for the most relevant records on certain topic, and it will give you that a few papers. So it's not as good as discriminative AI that we already have. For the full text screening, we have high hopes because large language models, if they could access the full text of the paper, they will have enough information to decide if a paper is relevant or not. So it could be a good game-changing if the existing systematic review tools implement large language models or embed large language models in the systems. For assessing risk of bias, it is challenging because it requires human judgment. We used to have robot reviewer, which is not publicly available right now, that assesses the risk of bias. And in 4 domains, it is as good as human, but not in all the domains. And it was just used for the risk of bias tool version 1 that was produced by Cochrane, not the version 2. We also can use large language models for risk of bias assessment. I'm aware of some of the existing programs, systematic review programs in the market that have implemented large language models for assessment of risk of bias, but it requires double checking by humans and human supervision. For data extraction, again, we have very good research papers around that show that they are working very good, 80%, 90% good, but there are missing data, there are miscalculations that require human check. The most recent research that I posted on LinkedIn yesterday was that we could actually use 2 large language models as 2 reviewers. So reviewer number 1 is GPT, reviewer number 2 is Cloudy, and then they could check each other's disagreement as well, and the human supervises them. For meta-analysis, they can be used, but the existing automation programs, data, let's say R, all of them are really efficient. We don't actually need to use AI for meta-analysis or network meta-analysis, but it is possible to use AI for conducting the analysis. And for grade, as I mentioned, for the risk of bias domain, it is almost good, but for the indirectness, inconsistency, and publication biases, it is not yet, and it may take a long time until it reaches that level. But what you need to know for using large language models, for using AI, the first lesson is don't jump onto ChatGPT for everything. There are really good, efficient tools specifically designed for scoping searches, specifically designed for assessment of risk of bias using large language models. So go for these specific tools and the specific large language models as well, rather than going for GPT and Cloud for everything. So that is the first lesson. And it's going to take time for people to learn it, but that is true. And it is going to be true for the rest of the ecosystem as well. Just because research shows that it works, it doesn't mean that it's going to work for you. The research is working because the people who've done that research, they have got AI expertise, method expertise, evidence synthesis expertise. There are 5-10 people coming around to do that research. If you've got that 5-10 people, then you could reproduce that results. The second thing is that research has taken months to be conducted. And if you want AI to do everything in a day or week, it's not going to work. So what you see in research is ideal. It is not reality. And finally, tech develops. So the GPT that you used 3 months ago is different from today's. So it might get actually worse because there are research showing that large language models, as they get larger and new versions come, in some aspects, they get actually worse, not better. And the most important tip is prompt engineering. If you don't know how to instruct the large language models to do the work for you, don't expect a miracle. Look at these large language models as intern, student, or research assistant that comes to your office, has no idea about the project, you need to explain by detail. The good thing is that If you had a research assistant, they will come back to you to say that I don't know this. I couldn't find this. Many large language models wouldn't do that. They are know-it-all. I mean, if there is no answer, they will still give you an answer. So very careful when you are using them. And you need to know typology of prompts, when to use what prompt. And there are classifications of prompt. And there aren't any good books. I've got one in front of me, and it is not good. The best guide for the prompts right now are the articles that people are publishing on medium.com, which are mainly the engineers, and I find them useful. But we don't have any guide. People need to learn. Another important thing for all the AI classes, garbage in, garbage out. The quality of output you are getting is dependent on the quality of your input. And input here is not just the file that you are uploading. It is also your expertise that is instructing the machine or teaching the machine, and then instructing the machine what output you want. If you are not expert, if the quality of file that you're uploading is not good, if the search results are clinical trial registry records, if they don't have abstract, if they are not in English, do not expect a miracle. So the quality of the input is very important. And then do not trust the systems until you do your tests, and always check and double check. Start with no trust. That is the policy that we have to implement and adopt for every use of any of the machines. There are some guidance. I think Grace mentioned the first one, and the second one is developing. Version 0.9 is available on Open Science Framework. Please do read them. And remember that humanities, law, and ethics are 2 decades behind science and tech. And that is from my experience. It is not evidence-based. It's going to take time until people realize that, actually, am I allowed to upload this copyrighted abstract or copyrighted PDF onto large language models? Is it ethical to use AI, considering the environmental impact that it has? And is it actually ethical to use it and not report it? So consider all of this. Sorry for providing a lot of information in short time. If you're interested for a deeper dive, there's going to be more opportunities to learn about using AI in evidence synthesis. And I will post some of them on our channel, youtube.com/@systematically.